Section 4.4, Exponential and Log Equations. So we are actually going to learn two methods for exponential equations and two methods for log equations. So there's quite a bit of material in Section 4.4. I will cover exponential in this first video and then do a second video for log equations. So first of all, how do I recognize when I have an exponential equation? And I will recognize it because it contains a variable in the exponent, which is how we defined exponential function at the beginning of Unit 4. So anytime there is a variable in the exponent, we call it exponential. So the first method for solving exponential equations is to write both sides of the equation with the same base. Okay. Now, it's actually not always possible to do that, which is why we are going to have a second method. But if it is possible to write both sides with the same base, then that's the route you want to go, because that is the easiest way to solve an exponential equation. Once you get both sides with the same base, then you can use the one-to-one property. And that property says if b to the m equals b to the n. So, in other words, you've got the same base on both sides. Then you can set the exponents equal. So that might be easier for you than looking at it in this math format. It just means set the exponents equal. Your variable will be in the exponent, so then you can solve for the variable. So let me show you what I mean with some examples. Number one, we see that our variable is up here in the exponent, and that's what makes it an exponential equation. And we look at that side and see that the base is 2. So my goal is to write the other side of the equation also with a base of 2. And maybe you know that right off the top of your head, and maybe you don't. So if not, then you want to just start calculating powers of 2. We'll start with 2 squared. 2 cubed is 8. 2 to the 4th is 16. So there we have it. We're going to replace the 16 with 2 to the 4th. We kind of did this concept, I believe it was in the last section, when we were trying to use property 3 and we needed to rewrite a number with a certain base. So this is that same idea. So we're going to come back over here to our equation. I'm just going to rewrite the left side, but the right side I'm going to replace the 16 with 2 to the 4th power. So now I have a base of 2 on the left side and the right side. Once I've accomplished that, then I can just set the exponents equal, because the only way this entire left side is going to equal this entire right side is if 3x minus 8 is equal to 4. So then we just go ahead and write down that as an equation and solve for x. This is just a little linear equation to solve, so we're going to add 8 to both sides and divide by 3, gives us x equals 4. So that is our solution. And certainly you can check these just like you would check any equation. We'll go ahead and show that here. I'm going to plug 4 back into my original equation and work out that left side. So in the exponent I'd have 12 minus 8, which would be 4. And if I calculate 2 to the 4th, I get 16. So it makes the equation true. Therefore, 4 is the correct solution. So these are really not too difficult, but let's keep practicing. So number 2, here's our variable x up in the exponent. We've got a base of 5 on that side. So my goal is to write the right side of the equation with a base of 5. So the first thing I see is the 125. So I want to write 125 as 5 to a power. So it turns out that 5 cubed is 125. However, I can't leave that 5 in the denominator, so to bring it to the top, all I have to do is change the sign on the exponent. So again, we had covered problems similar to this when we were learning the log properties. And here we have to use an exponent rule that says, okay, when you bring it to the top, you change the sign on the exponent. So now I've got this base of 5 on both sides. I'm just going to set the exponents equal. So I have 2 minus x on the left. I have a negative 3 on the right. And again, I just ended up with a linear equation to solve. I'm going to subtract 2 first, and then divide by negative 1. So I get x equals 5. And certainly you can go through and check all of these. I'm not going to show the check on every one, but just remember that you can check these. Okay. We'll do a couple more like this using what we're calling method 1. Number 3. So this x minus 2 over 6 is in the exponent. It's kind of hard to tell that in this font. So my base is 7. On the right side then, I also want a base of 7. Now I do have a 7, but I need to write it with an exponent instead of a radical. So if you remember, we can do that by doing 1 over whatever your root is. It's a square root, so it would be a 1/2 power. And now I have the same base on both sides. So I'm going to set my exponents equal x minus 2 over 6 equal to 1/2. And then I'm ready to solve that equation. It is still a linear equation because I don't have any variables in the denominator. I do have some fractions that I want to clear out. So let's find our LCD. Start with your big number. 2 will go into 6, so the LCD is 6. So I'm going to multiply both sides by 6 to clear my fraction out. So then I can say 6 goes into 6 once, 2 goes into 6 3 times. So on the left side, 1 times x minus 2 is just x minus 2. And on the right side, I get 1 times 3. Now, we could have also done this by cross-multiplying. Since you only have a single fraction on each side of the equal sign, you could do it that way as well. And maybe I'll show that. Let me finish this up, and then I'll go back and show that as well. So we're going to solve for x by adding 2. And that gives us x equals 5. If we had gone back to our equation here, and we decided to cross multiply to solve it, which it will only work if there's only one fraction on each side of the equal. But if we did it that way, then we would multiply these together, so 2 times x minus 2 equals, and then we multiply these together, so it'll be 6. And I can either distribute the 2 or divide by the 2. We'll go ahead and distribute. And then solve. So 2x equals 10, divide by 2, and we get x equals 5. So certainly if you prefer to solve it that way, then you are welcome to do so. Okay, let's do one more example of method 1. So remember, on this method, when I look at my original equation, I need to be thinking, how can I write both sides with the same base? And this one's a little different because it has an exponent on both sides. So the first thing you might do is say, okay, well, 4 is the smaller base, so let me try to write 8 as 4 to a power. Well, 4 squared is 16. So there is no way I'm going to write 8 as 4 to a whole number power. So if I can't do that, then I want to think about, well, could I change the base on both sides? So if I wanted to rewrite 4 as a whole number to a power, well, I could do that with 2, let's put it over here, squared. And then if I went to 2 cubed, I would get 8. So now 4 could be written with a base of 2, and 8 could also be written with a base of 2. So I will change the base on both sides. So 8 becomes 2 cubed. I'm going to put some parentheses around that and then also around my exponent. On the right, replace 4 with 2 squared and then put some parentheses around your exponent. Okay, so the next thing we want to do is simplify this a little bit using the exponent rule that says if I have a power to another power, I think the rule is written like this: a to the m to the n is a to the m times n. So when you have a power to another power, you multiply those, which means I need to multiply the 3 times the 1 minus x. I'm going to go and keep my base here. That 3 is going to distribute, so it becomes 3 minus 3x. And then on the right side, same thing, I'm going to multiply, which requires me to distribute the 2 and get 2x plus 4. Now I have just a base with an exponent on each side, and the base is the same, which is what I need. I need that base to be the same. Now I can equate the exponents. So 3 minus 3x equals 2x plus 4. And solve for x. I am going to, I'll subtract 2x and subtract 3. You could go the other direction if you prefer. That's going to give me a negative 5x, and 4 minus 3 will be 1. So I'm going to divide both sides by negative 5. And this time I end up with a fraction answer, negative 1/5. So don't assume that you're wrong if you get a fraction. Some of these will have fraction answers. It'll be a little tougher to check that, but certainly you could, and you can even use your calculator to check it if you would like. Okay, but now let's think about what if, I don't know, let's just say this right side had been 5 to the x plus 2. And now I had an 8 and a 5. There is no way that I could write those with the same base. And that is why we need a second method. So here is method 2. And this method actually will work for any exponential equation. So then you may be thinking, well, why don't we just use this one every time? Well, you're probably not going to like it as good as method 1. So if you can use method 1, then that is the way to go. And only resort to this if you have to. So let's look at the steps. Step 1, isolate the exponential expression. Now let's talk about what that means. Let's just say our exponential expression is, I don't know, e to the 5x. And we have some number in front of that. It's multiplied by it. And we have some number on the other side. So this e to the 5x would be considered the exponential expression, just the base with the exponent. To isolate it, which is what we're told to do for step 1, I would divide both sides by 4. And then I would have this exponential expression all by itself. Another possibility is maybe, we'll just use that same one, you have something added to it. In that case, to isolate, I would need to subtract the 4 on both sides. And then we would go to step 2 from there. But this is what we're talking about when we say isolate. We might have to divide, we might have to subtract or add, but your goal is to get that base with the exponent by itself. Okay, step 2. Take the common log on both sides for base 10. So if my base was, I don't know, let's say 10 to the x plus 2, then I would want to use common log. Take the natural log on both sides for bases other than 10. So if it's e or any other number, I'm going to use the natural log. So that's what we'll be using mostly. Step 3, simplify using one of the following properties. Now these are properties we've already learned. Let's just go through each of them here. If I have a base that is not 10 or e, then I am going to take the exponent and bring it down in front of the log because I'm going to need to get that x, my variable, out of the exponent. That was property 7 that we learned. Okay, look at the second one listed here. It's could be the same property, but if my base is e, if I had x log e, well, log e is 1. So x times 1 is just x. So the whole thing becomes x, and you don't even see the log anymore. Now, you can think of it like we just wrote out here, or this is also property 3, because you have an invisible e, and when these are the same, it's just equal to the exponent. And that's the same thing here for common log. Remember, there's an invisible 10. If these are the same, the whole thing becomes the exponent. So if it's e or 10, it's special. If it's not one of those, then you're still going to have a log. You're going to bring the x down in front of the log. And after you've used one of those, you will solve for the variable. So let's try some examples. It says solve, express the solution set in terms of natural logs or common logs. So number 1, we have an exponent on the left side. We have a base of 10, and it is already isolated. We don't have anything multiplied or added or subtracted to that base with the exponent. So step 1 is done. Step 2 is to take the log of both sides. And since my base is 10, I want to do common log. So I'm going to do log, just write that down and write it in front of the left side. Keep your equals and write it in front of the right side. Taking the log of both sides. Now, because my base is 10, remember this is special, there's an invisible 10, and since you've got 10 and 10, that whole side becomes what the exponent is, so it just becomes the x. Log of 80, I cannot evaluate. I can't write 80 as 10 to a power, so I'm just going to leave it log 80. That would be your exact answer. You do not have to give me a decimal answer. So just like that. So that one, very simple example, but we want to just practice learning the steps, and then they may get a little more complicated as we go. So number 2, here our base is e, and our exponent is 7x. So we're trying to get this e to the 7x by itself first. Step 1, isolate. So let's go ahead and add the 3. So I've got still the 4, e to the 7x equals 24. And then I need another step to get rid of that 4. I'm going to divide by it. And now I have isolated my exponential expression. So the next step is to take the log of both sides. And remember, if it's not base 10, any other base, especially e, we want to do natural log. So you're going to write ln, and then write the left side, equals ln, and then the right side. So this is a special one again. If it's ln and e, remember you've got your invisible e here, so these are the same. The whole side becomes the exponent, 7x. Log of 6 I cannot evaluate, so I'm just going to leave it. And now I need to solve for x, which requires me to divide by 7, both sides, the entire side. So I'm going to write my answer as natural log of 6, big fraction bar with a 7 below it. That is our exact answer. We don't want a decimal. Now you have to make sure the fraction bar is under the ln as well. If you were to write ln and then just 6/7, that would be wrong. Okay? Or maybe you had this and then you just stuck your 7 under the 6 instead of the whole thing. We don't want to do that. Make sure that the bar goes all the way across. In this instance, because we're dividing the entire right side by 7. Okay, let's try another one. On the left side, we have a base of 5, and we have an exponent. We do not have any other numbers on the left side, so step 1 is done. It is already isolated. So step 2, take the log of both sides. Since our base is not 10, I'm going to use natural log. So we're going to do ln, and write down the left side, ln, write down the right side. Now here, the ln's not going to go away because remember we have a little e here, but 5 and e are not the same. So I can't just turn the whole thing into the exponent. I have to use the property that says bring the exponent down in front. Put it in parentheses since there's more than one term. So we've got our x minus 3, and it's going to be written in front of log 5. Same level, put parentheses because the whole thing is multiplied by log 5, and we're going to leave log 137 as it is. And there's two ways we could go from here. We're trying to solve for x. One way would be to distribute the log 5 and then work on isolating the x term. Another way that you might like better in this particular equation would be, since these are multiplied together, I could divide by log 5 on both sides. And so then on the left side, if I divide these log 5s out, I would just have the x minus 3. And this right side is going to stay like it is. Kind of messy, but can't simplify that. And then last, to isolate my x, I would add 3. Now I cannot actually combine 3 with this fraction, so it would look like this. I would need to keep that log fraction. Then I'm going to put my plus 3 out to the side. And you could leave your answer in that form. So that's probably the easiest route to go to solve for x on that particular equation. All right, let's do one more. So this one has an exponent on both sides with the base, a base of 7 and base of 3. We don't have any other terms, so the exponential expression is already isolated. So step 1 is done. If it were possible to write 7 and 3 with the same base, I would certainly do that and use method 1, but it is not possible. So we're going to do log of both sides. Let's use ln. So ln of the left side equals ln of the right side. Okay, now since I have a 7 and a 3, I have to use the property of bring the exponent down in front like we did on number 3. So let's put it in parentheses. 2x plus 1 times log 7 equals x plus 2 times log 3. Now, if I tried to do what I did in number 3 and divide by log 7, I would still have an x on both sides of my equal sign, and then I'd have this fraction of logs in there. So that's not going to be the easiest route for this one. We are going to need to go ahead and distribute to get rid of the parentheses. So just think of this log 7 as one number, okay, which it is. It's a decimal number, and it's going to distribute to these two terms. And this log 3 is just a number, and it's going to distribute to these two terms. So I'm going to write it like this. I'm going to put the 2x in front of the log 7 because if I put it behind, you might be tempted to actually take the 7 times the 2x, which it cannot, okay? So we're going to write it 2x log 7 plus, and then we're doing 1 times log 7, which is just log 7. Now on the right side, we're doing x times log 3 plus 2 times log 3. All right, so we got rid of the parentheses. And now I've still got an x on the left and an x on the right. I need those terms with the x's to be on the same side. So I'm going to leave this 2x log 7 on the left. I'm going to subtract the x log 3 to move it to the left. Now my terms that do not have x, I want on the other side. So I've already got the 2 log 3 on the right side. I'm going to keep it there. I want to move the log 7, so I'm going to subtract it. So again, on that step, I want the x terms on one side. So here's an x, here's an x. And I want the non-x terms on the other side. So I left this one and I moved the log 7. Basically, I moved log 7 to the right and I moved x log 3 to the left. And it changes signs when you move it from one side to the other. Next, since I have an x in both of these terms, I'm going to factor out the x. So let's make a note. Factor. Factor out the x. And that's going to leave me 2 log 7 minus log 3. And I'm just going to leave the right side like it is. I cannot actually combine those. Then I can get x all by itself by dividing by what I have inside the parentheses. Divide both sides by that. And now my x is all by itself. And this right side cannot simplify. I cannot cancel when I have subtraction. Remember, I can only cancel over multiplication. So I'm going to just leave this big fraction. Now when you're doing the homework problems, if you have some like this, which I know there's at least one, your terms don't necessarily have to be in the same order as mine. Maybe on top you wrote minus log 7 first and then plus 2 log 3. That's okay. It doesn't matter the order of the terms as long as the signs are correct. Okay, so this is our answer. Now, there is one other type of exponential equation we want to look at. It looks a little crazy here. It may kind of remind you of when we solved polynomial equations. For example, something like x squared minus 4x plus 3 equals 0. And we tried to factor and set each factor equal to 0. Well, that's exactly what we're going to do here. So when you have two e's in the equation, use factoring to solve. So let's just go ahead and do this one real quick so we can apply that to our new problem. We know this is x and x because x times x equals x squared. So over here, whatever we put in front is going to have to multiply to be e to the 2x. So what if you put e to the x? Notice that's what's on your middle term. Just like over here we had an x on the middle term and that's what went in the front. So whatever is here is going to go in the front of both parentheses. Now if you're thinking, well, does that really work? If I do e to the x times e to the x, the exponent rule is keep the base and add the exponents x plus x. So yes, it does work when you FOIL it back together. And then the other part is just like it is here. I need factors of 3 that add to be 4, which are going to be 1 and 3. Exactly the same concept. So factors of 3 that add to be 4, 1 and 3. Signs. This tells me they are the same. And this tells me they are both minus. So it's going to be minus and minus. So if you FOILed that out, e to the x times, excuse me, let me go ahead and just show that real quick so you'll see that it works. E to the x times e to the x is e to the 2x. On the outside, you'd have a minus 3 e to the x. On the inside, you'd have a minus 1 e to the x. And last, you'd have a positive 3. And those two middle ones would combine, and it would equal your original. So we know now that that factoring works. Now once you've factored, the next step is to set each factor equal to 0. So e to the x minus 1 equals 0. E to the x minus 3 equals 0. And then you need to solve each of these, which are exponential equations themselves. So first step, isolate the e to the x. So here we're going to add 1. Here we're going to add 3. After you isolate, you take the log of both sides. And we want to use the natural log. So it'll be ln of e to the x equals ln of 1. And on the second one, ln of e to the x equals ln of 3. Now, because it's an ln and an e, it's special, right? Because we have an invisible e. So the whole left side becomes x. And we go x equals log 1. And log 1 is also special. We have a log property that says the log of 1 is always 0. That's the very first log property. So try to always remember those. Again, you can have those written down on your sheet of notes, but we want to evaluate when we can. So log of 1 is 0. Over here on our other equation, left side is x. Log of 3 cannot be evaluated. It would be a decimal that we would have to round, and we don't want to do that, so we're just going to leave that as log 3. So those are our solutions, 0 and log 3. We'll go ahead and try one more that's like that. So we want to try to solve it by factoring again. So we're going to make our parentheses. And look what's in the middle. This time it's e to the 2x. So that's what I'm going to put in the front. And when I multiply those, I want to make sure that's going to equal e to the 4x. And it will, because I would add the exponents, which would equal the 4x. All right, don't forget your equal 0. Now we need factors of 18 that subtract to be 3. So that's going to be 3 and 6. This minus tells me the signs are going to be different. So 1 plus, 1 minus. And this minus is going to go on the larger. So a minus 6 and a plus 3. set each of those equal to 0. And then we need to solve these exponential equations. So isolate on the first one, that means we're going to subtract 3. And on the second equation here, we're going to add 6. Next step, take the log of both sides. We want to use the ln. And since this is negative, I'm going to put it in parentheses, otherwise it'll kind of look like ln minus 3, and we don't really want it to look like that. So same thing on the second equation, ln of both sides. Well, as soon as you write ln of negative 3, then hopefully you'll be thinking, wait, I cannot take the log of a negative number. That's something we went over when we first started talking about logs. So it is important that you realize that here. So you could write another step down, but I would probably at this point just say log of negative 3. I can't do that. So I'm just going to mark this out and say, nope, I'm not going to have any solution from that equation. Now this one is log of a positive number, so we can keep going on it. Let's just make a note over here. Cannot take the log, ln or log, of a negative number. And that's why we are stopping on that one. Okay, back to the right equation. On the left side, we are just going to end up with our exponent, 2x. We're going to keep log 6 on the right. And then we're going to isolate x by dividing by 2, the entire side by 2. Remember to make your fraction bar all the way across. And we're going to leave the answer as log 6 all divided by 2. So just one solution for that equation. Okay, so I know that was kind of a lot to cover. I would go ahead and practice the exponential equations from the homework, and then I'll cover the log equations in a second video.